What's up? Here's a Minecraft video for you all. If there's one thing I hate that isn't gravel, that's an inventory filled to the brim with garbage. It's infuriating. The absolute worst time for this to happen is when I'm underground. Like for example, one minute I find something cool in the cave after looking for a while, only to realize that I can't collect it because my inventory is full of this stuff. That raises the question as to how I should deal with the situation. My first instinct would be to clear out the stuff I don't want, like flint for example. After that is said and done, we have our wanted materials, so the next thing to do now is to put them in a safe place so that the next time I get blown up behind my back, I can still access my stuff without having to worry about the items disappearing later. The only obvious solution to this conundrum is storage. Storage is pretty cool. It's like a full other set of inventory space, except it can stay in one place, and or be taken wherever you want. If we didn't have it, the game would be a lot harder to beat. Unless you're a speedrunner, then you don't have to worry about such a thing. Yeah, best thing since sliced bread, I know. As you might have expected, if you watched my previous video on Red Ribbon's scoring system, boop, there is a lot that comes to storage, and I thought it would be fun to look into it, see how it works, and maybe even have a fun time with it in the process. If you wanted to get a little bit experienced in the game, it would be a good idea to understand the many ways as to how to store things in Minecraft, and know which ones to use, especially if you are a beginner. You can actually use a variety of blocks to do so, like a lot, but some of these are more practical than others. The most common one that you all have used at least once in your gameplay experience, even if you only played it once or twice, is this thing, a chest. This is a pretty old item. It's the granddaddy of storing things in Minecraft. It was first added in the in-dev phase of development all the way back in January 2010, and functions much the same as it does today. All it needs to do is just store a bunch of stuff and recall them when the player interacts with the block again. Easy. And if you give it a bit more time and wait until it hits the inf-dev phase, then you start to have other blocks that store things in some capacity. The next one that was developed was the furnace. Easy enough, you could just put something in there and leave it there. But it isn't 2010 anymore now, is it? The game is a lot more complicated now, so as expected, we have many blocks that we can use to store things. For example, you hear about the barrel blocks being a slightly cheaper option to chests. Another one of these blocks is the ender chests being a way to access the same set of things you put in a rough desert somewhere as you would anywhere, even in the comfort of your own home. Considering you have enough materials to make another ender chest, they're endgame for a reason. If you're in an anarchy server, that shouldn't be a problem because these things are literally everywhere. After all, you have other things to worry about when you're there. Shulker boxes are a lot like chests and barrels, except its selling point, or in this case, crafting point, is that it has that extra use of portability, meaning you could have an inventory in an inventory. Pretty sweet. When they were added, the maximum amount of things that you could hold in your inventory in survival mode were multiplied by quite a lot, 37 times to be exact. 1.18 is coming up in the next few months, so it would be worth mentioning the bundle too. The bundle is like a worse version of the shulker box. It stores a small amount of things in one slot. It's probably gonna be something I'll play around with once and never use again, I don't know. There's enough items to store things in Minecraft that there's even a chest in a minecart implemented in the game. What it does is store things the same way a regular chest does, and then add the ability to move it around a track. It's storage that moves. It's literally just that. Moving on. Remember, this is only the first set of storage blocks that come to mind when we are storing things, or as I like to call them, the normal way to do it, because when we think a little bit harder, you'll find that things like hoppers, minecart or not, dispensers, beehives, brewing stands, droppers, and the furnaces that I mentioned before technically do the same thing. But since this is a Sys128 video, we need to go all out. We can point out every single item that is capable of holding something, right? So this means we're not leaving out the armor stands, flower pots, item frames, campfires, lead nuts, jukeboxes, and lecterns for storing types of items. We can also count enchanted items for storing enchantments in your tools, the signs, the books and quills, and written books for storing text, and the spawner minecarts for storing information about the spawner as to what mob to spawn. This last one could be up to your interpretation, but we could, emphasis on could, count you, yes you, as a way to store things. You have an inventory for a reason, right? That's evidence enough for me. There's a lot more that I have undoubtedly missed. If you want to list a few more, go ahead. So now that we have quite a few examples of items that can store something, you're probably looking for the short of it. I'm talking about things that can store extra information at all. There is quite the specialty between these blocks and items, as well as some core differences. And no, it's not just how many items they can hold, or how many slots they have. There's quite a few more things that I want to mention, but we'll cross that bridge when we come to it. I aim to start surface level, and then work our way down from there. Enough of me rambling, let's get into it. For this comparison, we will be taking a look at blocks and items that can hold things from your inventory instead of any other means of storage, just to slim down the list and make it easier for us. This section will be kinda quick because this is just some of the more boring stuff coming up first. So first off, here's a quick thing that sets these items apart before we get into some of the juicier stuff. Some of them can be generated naturally, while others have to be crafted by the player as the only way to obtain these items. Well, most of these items can spawn naturally, some of which are the types of furnaces and various types of villages, but that's nothing compared to our old pal, the chest. The chest can appear in dungeons, temples, strongholds, nether fortresses, ruined portals, and these other thingies, and that's a lot. These things specifically are particularly everywhere, but things like the hopper and the shulker box would have to be crafted by hand in order to be obtained. Another one of the main differences between these is their purpose. While yes, all these can technically be used to store items, for a lot of these it's not exactly what they're intended to do per se. Like for example, you have the furnace and its cooler siblings once again, which all of them have the intended purposes of cooking and smelting items. Considering that this is the Java edition of the game at least, we can put anything in the top slot, but the bottom slot would have to be a type of fuel. So if we put a shulker box filled to the brim with stuff on the top slot, and a stack of coal in the bottom slot, after smelting another stack of items beforehand, in vanilla survival, you can fit up to 1,857 items inside of a furnace or equivalent. With extra MBT data and chests and stuff like that, you could theoretically fit infinitely many items in one slot, which was something Anvenom tested a while back. If I remember to put a card to that video in the corner, then it'll be there. Well, we'll see. A few more quick examples. Without cheats, 8,645 items can be stored in a hopper, 1,728 for a shulker box, since you can't put other shulker boxes inside itself. That would mean that you can store 46,683 items in a regular chest, meaning every item in each shulker box plus the shulker box itself. Therefore, 93,366 items can be stored in a double chest. There are some items that have no way of holding some specific items because it needs to push its intended purpose. This is applied to armor stands, which is normally used to display your armor, and or flex on your friends that you have an extra armor set you'd probably never use. Fun fact, it's a little known fact that armor stands with arms can be summoned in the Java edition, so it's not a Bedrock exclusive. You just need to use this command instead of just placing an armor stand. And there you go, an armor stand with arms. Armless armor stands can only have a set of armor applied to them, and since armor cannot be stacked without an exploit of some sort, an armless armor stand can only hold a pitiful 4 items. Ugh. But of course, if you had a data pack that allowed for the armor stands to have arms, the armor stands now have a couple extra slots for the ability to hold anything. So with armor stands with arms, the max number of items goes from a lousy 4 to a manageable 1,733. That really puts the arm in armor stand, doesn't it? Other than that, there's not a lot to mention when it comes to differences like this. I'll have to mention that these storage items need a way to pull off their ability to store items in the first place. Well, but how does it do it? Well, that's what you're about to find out. For almost every single one of these items, we can place it somewhere in our world. sorry bundles. Most of these are around a meter tall or less, so we tend to call the majority of these just blocks. But don't let this block-esque thing deceive you, because I'm about to prove that you have been lied to about these things. That's a bit of an exaggeration, but anyways. You see these things? Yeah, those are literally more so entities just as much as they are blocks. At that, it's a different type of entity, so it's not an entity in the same way that a creeper or a pig is an entity. Or something like that. No. Chests and all other storage mediums, beehives and nests, yada yada yada, and a ton more fall under a category of blocks known as block entities. Because of course, it's both a block and an entity. Wow. This is assuming you're on the modern version, as a lot of these were used to be referred to as tile entities until the release 1.8 snapshots, when they were changed to block entities. So now that we have uncovered the truth about what these blocks are, what are block entities exactly? The answer is pretty simple. The main purpose of block entities is to store extra information about what the block is currently being used for, i.e., cooking food, enchanting your netherite pickaxe to have Unbreaking 3 and mending, or what you want to save within a structure block, for a few examples. In the case of a mainstream storage, this is to keep a separate inventory. Some block entities render differently from others. There are a few factors that contribute to such practice. One of these is that the blocks and/or elements of it stop rendering at a certain distance away from the player. For example, chests and shulkers stop rendering when the player is 64 or more blocks away from it. Each of the affected blocks have a hard-coded limit and cannot be changed unless you're specifically modding the game to do so. This means that the render distance of the terrain may not change this hard-coded limit, but can still disappear if the render distance is low enough. However, it also applies to even the entity distance scale, because it is mainly used to affect traditional mobs and item entities. No matter what percentage it is set to, they stay the same. Before we move forward past the block entity phase, I figured that it would be kinda cool to dive a little deeper into the extra data bit of what makes these block entities so special. Perhaps we should introduce the backbone to what makes these things tick. Are you ready for NBT tags? Minecraft needs a way to store extra information about some things in the game. This is where we introduce the NBT format. The term NBT is short for Named Binary Tag. A named binary tag is used for storing extra information about every different block entity in your world. But there are many other uses of these tags outside of block entities. These tags are also used for items, like for example, if your items happen to be enchanted and/or have a custom name applied to it. So if you took a second to notice that the weird names on items you find in a friend's server, now you know that there's an NBT tag that's making it happen. An NBT tag can also be used to track the durability of an item, if applicable. Otherwise, it wouldn't be as much fun to have an unbreakable item, would it? Another set of things that NBT tags can be used for is when items drop onto the ground, which the moment it does that, oops, it's an entity now. Usually, they are used for the exact same reason that an item would need NBT tags, the durability, enchantments, and name. They would need to have the exact same characteristics of the items themselves, because they would also have to be identified as to what item has been dropped from the source, so that the item doesn't magically turn into something else. Item entities also have a health system and a timer for when the item is set to disappear. In regular cases, it will automatically disappear when 6,000 in-game ticks have passed, which would optimally be equivalent to 5 minutes. The item will also disappear if the health is set to 0, like if it were to be thrown at a cactus or into a pit of lava. The item's position, rotation, and movement are also set and are constantly updated with NBT tags. Perhaps two of the most important uses of these tags are for mob entities, and especially player entities themselves, because a creeper needs to blow you up without you looking somehow. NBT tags help identify what exactly the mob that you are interacting with is. We can use the villager as an example because of how useful these tags are to them. In the case of this cool-looking long-nosed villager, NBT tags can control what profession they have, how much players have traded with this villager, aka their profession level, what their main hand is, what they are offering to the player, what biome they belong in, and the rest of a long list. Villagers have 19 tags that help make it unique amongst its neighbors as of the 1.16 Java update. Now, the player. You, basically, have almost too many to count, around 44 tags. You see, there's a lot about you in your world. If I were to explain everything about you, it would take up quite a bit of time and would deserve its own separate video. A few of these tags are where you are in your world, how much experience you have, where you should spawn when you die, whether you're dead or not, what's in your inventory, and a lot more. Next on the list of NBT-filled things are projectiles like fireballs for things like explosion power, velocity, and direction, and splash potions for the same, except it doesn't explode, it gives off an effect within a certain range instead, and vehicles like boats and minecarts for their position, rotation, velocity, etc. Don't worry, we're almost done. Hopper and chest minecarts also hold inventories that are the same as their block entity counterparts, along with their, say it with me, position, rotation, and velocity. This would pretty much explain how chest and hopper minecarts can also store items inside of them, just like how regular chests and minecarts do so. Other examples of items that can have NBT tags attached to them is the boolean indicating the stability of a piece of TNT, diffused of its prime counterpart, the falling block's block that is falling, therefore making it a falling block, fireworks for distance, and if, when, and how it goes boom. Paintings for the diversity of its random choice of designs, and whatever is being held in an item frame. Whew, I think that's enough examples for me to handle. That pretty much comes to show how useful these are for adding more possibilities to things in the game and just to make it function overall. Furthermore, we now have the knowledge to know how NBT tags are utilized in a storage block, like our old friend, the chest. To find out exactly how the NBT tags are laid out, I will be using NBT Explorer, but of course since I'm running it on Linux, I have to go through a few extra steps to install it, but that doesn't stop me. Here's a screenshot of a double chest I put in a testing world, in some of its NBT glory, complete with all of the slots that have something stored in it. As we can see, there are not 54 entries in total for what is inside the double chest. One of these factors that contribute to this is that if there is nothing in a slot, no NBT data will be created for it. In this case, we have 13 slots in this half of the chest, and every one of the slots that show up have one barrel inside of it. You might have noticed that I alluded to the fact that there are two separate groups for this double chest instead of having it all in one. What gives? That is because every group of NBT data for a block entity is limited to one block. One group here controls the NBT data for half of this double chest, and the other half is dedicated to the other side of the chest. This results in half of the chest contents being dropped along with one of the chests after one of the sides are broken due to it being based off the NBT data for that block, while the NBT data for the other half still remains in the other chest. Inside of one of these slot entries, it is revealed that all of the tags that keep in an order are how many of this thing are in that slot, what it is, and what slot it is located in. Of course, the position also has to be identified, as well as something that indicates that it is a chest to begin with. There is also this little tag here that indicates an invalidated block entity, which is more useful in world generation, so in our cases, this tag does nothing. There are also some optional tags that a chest can have. A chest can be locked, so that can only be opened when holding an item that has a certain name attached to it. Loot tables inside of each single chest can also be set so that upon opening or otherwise interacting with it, it will go through a random assortment of items. For the sake of being more random, each chest containing loot can also be assigned a seed. There are many instances in a normal world where this is done, like villages, dungeons, temples, and cities, nether fortresses, and bastions, to name a few. Another interesting thing about loot in Minecraft is that once the loot has been generated, the tags relating to the loot delete themselves, so that loot is not regenerated when it is opened again. Otherwise, that's just another duplication exploit that so many people are just waiting to do. Now, there are my reasons for why chests are a pretty cool block entity, but now, let's change it up a bit. Let's get into why they kinda suck. Another useful thing about some blocks in the game, more notably used in a lot of the block entities in the game, is that they can have a model associated with it that blocks like cobblestone cannot mimic. For example, just look at all of the items that can be stored on a campfire along with how its logs give it more form. Chests are one of those cool kid blocks that have a model associated with it, but it isn't how it's cracked up to be. Because of this, I would say that this is not quite my favorite way to store things in a large capacity. The downside of having more detailed block models is of course more faces to render, which in turn can result in drops in the client's frames per second, but the models are nothing compared to the other thing that makes these chests so laggy. The other factor to why it can lag the game so much comes down to the animations. Since every chest in the loaded area is being animated, the game would need more time to process it on the graphical front, which is the even larger drop to the frames per second. The same fate can be shown for shulker boxes because of the animations that it also has to play. So of course, this would affect every block that has animations associated with it. So in conclusion, if you are making a large storage system and looking for performance, doing so at a bunch of chests wouldn't be a very good option because of both the geometry used to make up every single chest and the mere fact that bits of it can move. But of course, counter to your performance, especially if your computer is a potato and or is over 10 years old like mine. It's bad news for my old HD 5870 graphics card and Athlon X4 620 processor. You see, I am the type of person that would want to know everything when it comes to performance, and that should be a bad sign for a good old chest. To show you this chest lag in action, unscripted Sys128 can take it from here with some lag tests. Ah, right. He must be stalling again. Or is it a school day? I don't know. School seems to have just started. Oh, never mind, it's the afternoon. Now, unscripted Sys128 will take it from here. As you can see, I am currently in a completely empty world. Our base FPS is around 300 with the HUD on, and 500 with the HUD off, or more. We can do another test to make sure. Yeah, around almost 600 there. So, our first test is to fill in a bunch of chests. And instantly our frame rate drops to around 20 FPS. The HUD off, it's around the same. We don't see much improvement. So this should prove alone that chests are a very laggy block. And a storage system would ultimately be not quite done with just chests, because it's got all this stuff going on with it. We do a hopper, something with more geometry. We can see that performance doesn't take as big of a dip. You're getting around 200 FPS. With the HUD off, it rises to about 480, 480. And our last stop is our barrel, the less laggier chest counterpart. Something with barrels is that you can't really combine it to make a double barrel, but I think that's a good sacrifice if you're looking for more performance like me. You see, we're getting around 235, 250 FPS with the HUD on, and with the HUD off, we're getting around 400, 370, 424. It's around the same as the hopper. So if you're looking for the most performance bang for your buck, I'd say just go for the barrel instead of the chest. As you can see, the barrel blocks are the best way to go when it comes to a lightweight storage system because for one, they do not have extra geometry and act as a regular block on the visual front, and therefore, they would also not have any of those clunky animations chests have, thus leaving your frames per second just about as stable as them not being there at all. It's a truly wonderful thing. And it's not just performance that makes the barrel something that the chest just wishes it could be. For a chest, it can be placed anywhere, except if there's a fully solid block on top of it. When this happens, it prevents the chest from being able to open because of obvious reasons. This can be worked around with the use of slabs and stairs, but with the barrel block, it's no biggie. You can put whatever you want on it, and it'll just work. What a way to handle it like a champ! On top of all that, the crafting recipe for this block is a little bit cheaper than a chest. It just needs a little less than 8 planks to craft, because 2 of the blocks are replaced with slabs. But it can get better. If you are a bug rock player, it is even cheaper. Instead, all you need is 6 sticks and 2 slabs, and that's it. And the only compromise is that you can't make a double barrel, and that's it. Other than that, it just functions like a regular chest would. Also, I think it would be worth mentioning that I should be realistic for a second. Of course, not everyone's gonna agree with me on the whole barrel thing. If you still want to use chess after this, whatever. If your game is still playable after completing your storage system, then go for it. You can have your opinions and I can have mine. That should stall the Twitter mob for a little bit. I think that's a good enough ending for me. This video is long enough as it is, so that should give you a perspective as to how exactly storage in Minecraft works, with the added bonus of other stupid and not so stupid ways that it can be done. You know, just for the fun of it in the end. I'd say it was an adequate run-through of the fundamentals and some of the fun ways it can be interpreted. Before I end this off, I do have an idea that has been in the back of my mind for a while. I was thinking of eventually doing a miscellaneous series which I answer some questions about a certain game in the comments, and then going through a shorter deep dive into them to answer said questions. But I don't think I have enough to work with quite yet. I'm still working with a small channel after all. You know, I would ask you to do something, but I don't quite know what it is. Something about, never mind. How embarrassing of me. Anyways, this has been another video in your watch history, and until my next upload, here's a picture of my cat. Bye.